Students, today I will discuss convergence of sequence and series. So now let us start. What is sequence and series of function? Sequence is a function whose domain is the set of all natural numbers. Domain can be anything. It is real number, so it is called a sequence of a real number. And if it is complex number, then the sequence is a complex sequence of matrix, vectors, etc. So the function defined is a very different thing. Let us fix one set. Suppose a non-empty set E, which is non-empty, and assume that all sets are defined from this set. E will be subset of all matrix space, and most of the application it will be some interval. Suppose E interval of A B, and n element of n Fn is a sequence of a function. Fn is a sequence of a function. X element of E, and Fnx is a sequence of real number. Fn of x is a sequence of a real number. We can say that Fnx convergence converges for all x element of a E non-empty set. Then we can define f of E which convergence to R, f of x which limit of f of Fnx, and x element of E. So Fn convergence f pointwise. A sequence Fnx is a real number convergence to a real number. Fnx convergence to f of x which x element of E, and suppose a sequence Fnx equal to xn which is 0 interval of 0 and greater than equals to 1, and so you define f of x equals to 0 which is 0 interval of x and 1 and equals to 1 which x equals to 1. Then f of n convergence to f pointwise. As you know, a sequence as well as a series, as per as the consideration of convergence or a divergence of a sequence, series is convergent. Whatever fast you does not matter, finite number of terms can be inserted of the sequence and series. So a sequence is a remain convergence and the divergence of series is remain divergent. Suppose Sn is a sequence. Suppose we take a sequence Sn is a sequence of a partial sum which Sn equals to f1 plus f2 plus fn, which is partial sum, and is fn convergence to R. And इसका मीनिंग क्या है? Summation of n equals to n tending into infinity fn, sigma of fn which equals to f1 f2 fn. If Sn convergence to G pointwise, we said that summation of fn convergence to G pointwise, and G is equal to the sum of summation n equals to 1 to infinity fn equals to G. Suppose fn have some properties, then the limit also have properties. Example, continuity. Suppose each fn is continuous, then G is also continuity. Suppose each fn is integrable, then G is also integrable. अगर हमारे पास कोई भी सीरीज है तो ये कन्वर्जेंट कब होगा, इसके आगे क्या होता है ये आज मैं समझाऊंगी. Sequence of partial sum of series. Suppose a sequence n which is equals to 1 by 2 to the power n is a sequence which is equals to 1 by 2 to the power square 1 by 2 cube which is equals to 2 to the power n SOPS. एंड ये सीक्वेंस का पहला टर्म क्या होगा 1 by 2, एंड दूसरा टर्म 1 by 2 plus 1 by 2 स्क्वायर, तीसरा 1 by 2 स्क्वायर 1 by 2 क्यूब which is equals to un this term, and this term which is equals to sum of n equals to 1 to infinity 1 by 2 to the power n which is equals to limit of n to the power infinite n tends to infinite un. ये इस सीरीज का जो सम होगा इसके साथ सेम होगा. किसके साथ? लिमिट n टेंडिंग इनटू इनफाइनाइट 1 by 2 1 minus 1 by 2 n 1 minus 1 by 2 इसके साथ सेम होगा. सो ये सीरीज फाइनाइट होगा, एंड ये सीक्वेंस जो सीरीज होगा तो ये कन्वर्जेंट हो जाएगा क्योंकि n टेंडिंग इनटू इनफाइनाइट, तो ये दिस टर्म इज 0. सो 1 by 2 by 1 by 2 which is equals to 1 is finite series which is sum equals to 1. So series is convergent. Let us take another example. Consider the sequence of complex numbers. Suppose Zn equals to n plus I divided by n plus 1. Does the sequence convergence? If so, find limit. So Zn equals to n plus I by n plus 1 which is equals to n plus I. Suppose we multiply n plus 1 plus I n plus 1 whole square, n square plus n divided by n plus 1 whole square plus I n plus 1 divided by n plus 1 whole square. So this is the real term and this is imaginary term. Real and imaginary term. First we take limit n turning into infinite n square, this term n square plus n by n plus 1 whole square. Suppose common n square 1 by 1 plus 1 by n, which is equals to n square plus 1 plus 2n. Also we take common n square 1 plus 1 by square plus 2 by n. The n square 1 plus 1 by n square cancel, 1 by 1 equals to 1. And the second term limit n turning into infinite 1 by n plus 1 cancel into 1 by 1 plus 1, which is 0, which is 0. So this real part convergence to 1 and the imaginary part convergence to 0. The sequence Zn convergence. Limit n turning into infinite Zn equals to 1 plus 0I, which is equals to 1. The sequence Zn convergence and its limit is 1.